Solve by elimination. 3x plus 2y equals 9, and 3x minus 2y equals negative 3. This would be a particularly difficult problem to solve by substitution because each of the variables has a leading coefficient, and so if we tried to isolate any of the variables here, we would be dividing by something that would give us fractions. So we can use substitution here, but no matter which variable we try to isolate, we're going to end up with fractions. Instead, we're going to use a different method that's called elimination. Now, this problem is set up perfectly for elimination. Some of the other ones are going to require a few additional steps, but this one is set up perfectly. So what we're going to do is we're going to line up the equations on top of each other. We're going to stack them. 3x plus 2y equals 9, and 3x minus 2y equals negative 3. And we're going to do something that we've never done before. We're going to take two equations and we are going to add them together. Now, some people use a regular addition sign when they add two equations. I think that it's something special. It's a little bit different from what we've seen before. So I make more of a cartoon plus sign. It's nothing official. I just do it slightly differently to draw attention to the fact that we're doing something we've never done before. This is allowed by the properties of equality because in an equation, the left-hand side is equivalent to the right-hand side. So when we're adding a second equation to a first equation, we're really adding equal quantities because the two sides are equal. Now, in this problem, when we add the two equations together, something interesting happens. If you look at the x's, 3x plus 3x is 6x. But if you look at the y's, negative 2y plus 2y gives us 0. Those are opposite terms, and so when we add them, they cancel out. They are eliminated. That's why this is called the elimination method, because we are eliminating one of the variables when we add them together. So on the left, we only have 6x. Now on the right, 9 minus 3, or 9 plus negative 3, gives us 6. And because we've eliminated the y, we can easily solve for x. If we have 6x equals 6, we can divide both sides by 6, and that gives us x equals 1. We were able to get the value of x without having any fractions, which makes this a slightly more desirable method than substitution in this particular situation. Now we're not finished. We've got the value for x, we still need the value for y, and we're still going to use substitution like we did before. We're going to pick either of the original equations. I'm going to pick 3x plus 2y equals 9. I don't see the need to deal with negative signs if we can avoid it. And I'm going to substitute in the value for x that we just found. So instead of x, it's going to be 1, making this 3 times 1 plus 2y equals 9. 3 times 1 is 3, so 3 plus 2y equals 9. We're wanting to solve for y, so we subtract 3 from both sides of the equation. This gives us 2y equals 6. And to get y alone, we divide by 2. This gives us y equals 3. So our final answer is going to be x equals 1 and y equals 3.